Here's the section 2.5 PowerPoint video I promised, so that you can keep working even when I'm not here. Remember that section 2.5 starts on page 199 of your text. And also remember that going in, I asked you to remember 6 graphs. And I'm going to let me get a piece of graph paper here so that you can actually make sense of them. Remember, here's the first graph. Look at that, even with the piece of graph paper. Where this is the x-axis, this is the y-axis. Okay, and this is your graph right here. Notice it starts at the origin. So this is a linear. And the function that gives us this is f of x, or y, is equal to x. So whatever x is, that is y as well. And the second of the 6 graphs that I asked you to know was the squaring. I don't usually call it squaring, though. I usually call it quadratic. There's an entire chapter that we'll start next dedicated to nothing but quadratic functions. And remember what it looks like. Here's our axis, and it looks like so. Also, the vertex is on the origin. Another that we have to have is square root. Oh, this one here is y is equal to x squared. That's the function that generates it. This one, y is equal to the square root of x. And remember, it looks like so. We also have the cubing function. That looks kind of like a snake. Y is equal to x cubed. And then the last two are the reciprocal function, which is y is equal to 1 over x. And it kind of looks like this. Remember, these are called asymptotes. They're hugging but not ever going to touch that line. And then the last one is absolute value. Okay, y is equal like so. And here's our piece of graph paper. And it looks like a V. Now these two, the quadratic and the absolute value, if you're not careful, it's easy to get those mixed up. So make sure that you round that bottom on the quadratic and make sure that they're good sharp lines on the absolute value. Okay, and then this section, remember, was all about let's mess with those now. Okay, we're going to be able to transform it by translating it left, right, up, or down, reflecting it across either the x or the y axis, stretching it, or shrinking it. And the first is vertical translation. That means you're taking the parent, which is in green in this case, and you are translating it either up or down. And please pay attention. Now this is all outlined for you, like I think it's page 208 of your text, that says if we have all these math words here. For if our b, and remember this is b, okay, remember that from Algebra 1, if it's greater than 0, that means it's positive. That's a plus sign right here. Then that's going to translate it up, okay, that many units. If it is negative, it's going to be pushed down that many units, this negative right here. So you draw the parent, okay, and notice that this 3 here is going to make it taller and skinnier, and then you scoot the whole thing down that many units. Horizontal is exactly what it says. You take your parent function and then you are either going to translate it left or right. Remember, if it's a horizontal translation, 2 things must be true. Remember that inside here, anything that's inside is called the argument. Okay, the argument. And if it's inside here, a negative makes it go to the right, a positive makes it go to the left. Okay, so you have your original, and then you're either scooting it left if it's a plus, right if it's a minus. Let's remember those horizontal translations as well. And then we have reflecting. Reflecting across the x-axis. Please be sure that you get this. If the negative is on the outside of the function, away from the argument, it reflects it across the x. So if it was up here, okay, now it's going to be turned upside down. So now it's going to look like so. Okay? If it's inside with the argument, it's going to reflect it across the y-axis. So be very sure that you get that. Reflecting across the y is not near as common in college algebra as it is in like calculus, but reflecting across the x happens all the time. Okay. And here's you an example. This is being reflected across the x-axis. This negative in front of that 4 flips that upside down. Okay? So the green is the original parent, and then the blue here is where it's been flipped upside down across the x-axis. And you can see that here's the green again is our original. This is our original. Okay. You know what? Let me change my pen color because they did this in green and I should have too. So here's our original here with this green. And then in the blue, you can see it's been reflected now across the x-axis. It's just this has been flipped up and this has also been flipped up. So it is, or it was up here, and so it's been flipped. Notice these two are together, and then this, where it was heading uphill, now it's heading downhill. So it's been reflected, the entire graph across the x-axis. Okay, and now this one across the y-axis, please notice what's happening here. Again, the green is your original here, and the blue, it's just taken it and folded it over. Okay, so it's just been flipped across the y-axis vertically. Okay. And then stretching and shrinking. I really only want to talk about vertical stretching and shrinking right now. Horizontal can be confusing, but vertical stretching and shrinking means, is the graph according to the parent or the original, is it going to be tall and skinny compared to that, or shorter and fat and wider than the original? And so if you have, and notice what we have right here, here's our function, our parent function, and here's the a in front. So we're adding some number a. Okay, that can be 12, 42, 3, -2, 1/2, any number at all that we're letting this a be. If this a right here is greater than 1, so it's a positive number, positive whole number, then it's going to make that graph taller and skinnier. It's going to, we call that stretching vertically. Okay, if this in front of here is a fraction in between 0 and 1, so 1/2, 1/3, 1/4, this is going to make it wider. Okay, and notice how you obtain the coordinates of your y so that you can see. You take the original function and you multiply each of the y coordinates by whatever a is. So if a is 1/2 and my y is 4, now my y is going to end up being 2. If my a was 10 and if my my y value is 10 and my a is 1/2, now my new y value is going to be 5. So it's just going to make everything shrunk by that factor. Okay? And now, let's be sure that you can put them together. Okay? Notice this 2 in front makes it stretch. It's much taller than the original. The original here is in black, and it makes everything taller, and also makes the bottom there lower. Okay? Because every value gets multiplied. Okay? The same thing here. Look how much wider that pink is because of that 1/10. That's a fraction, and fractions make it wider, and you see how that works as well. Now, I do want to spend some time here and making sure that you can do multiple things. Okay? Notice here it's being stretched because of that 2. Okay? The 2, it's the only thing that 2 is doing is making it taller. See, the yellow is taller than its parent. Taller and skinnier. But what does this negative do? It does something totally different. It's what reflects it across the Y. Flips it over right on its pivot points here. You just turn it right there. Okay, that's super important that you get that. All right? And then this again is shrinking or stretching horizontally. And it's a little, again, notice where our variable is. Sorry about that. Let me go back. Okay, notice here, right here, where our letter is, here our C. This is what we're multiplying by. It is inside with the argument. If it is greater than 1, it shrinks it. You'd think, oh, it should grow it, but it actually shrinks it. If it is a fraction, it stretches it. And it, just like everything else that's along the y-axis, it's opposite what you think it should be. So if it's a greater than 1 number, it's going to make it flatten it sort of against that x-axis. Okay? If it's a fraction, it's going to make it tall and skinny. Those are a little harder to get, but here's just a couple of examples. Notice that our 2 there is inside the parentheses according to the original right there. I don't think this is the best example that ever there was, but I don't want you to be as concerned with the vertical stretching and shrinking. I'm sorry, the horizontal stretching and shrinking as you are the vertical stretching and shrinking. But notice actually what happens with this green. I want you to think about it as stretching it or shrinking it along the x-axis. Okay, it flattens it more towards the x-axis. All right, I hope that that's pretty clear and that you can be able to see those and that this little video helped you understand.